Before noon even hits, the streets in India's most populated cities are empty. The air is so aggressive, it physically burns to stand outside. While 40 to 45 degrees Celsius is the expected summer baseline across much of the country, this season is behaving differently. The heat is arriving earlier and staying longer, forcing millions into a constant defensive posture against the sun. You can see the severity of it in the environment. At places like Sansei Lake in Delhi, rapid evaporation and a lack of fresh water supply dried up huge sections of the lakebed so quickly that hundreds of fish died. This graph shows a specific shift in the weather pattern. Normally, the summer temperature cycle dips into a cooler blue zone at night, but right now, the country is experiencing a warm night condition, where that temperature line stays flat and trapped in the red zone until morning. That gap between the lines represents a massive physical problem. During the day, the human body absorbs heat. It relies on the cooler night air to drop its core temperature and recover. Without that nighttime drop, the body is locked into a state of continuous stress. When a body never cools down, it eventually starts to fail. This combination of daytime peaks and nighttime stagnation transforms a change of seasons into a physiological trap, a test of biological endurance that India is just beginning to enter. The first factor keeping the heat locked in is a high-pressure system. It acts as an invisible lid pressing down on the atmosphere, suppressing cloud formation and blocking hot air at the surface from escaping upward. Because the heat cannot rise, the ground absorbs the solar radiation and warms the stagnant air above it. That trapped air bounces the heat back down, which warms the ground even more. Earth and sky begin trading the exact same heat back and forth, driving the temperature higher with every cycle. Normally, the ground has a defense mechanism against this: soil moisture. Damp earth uses a large portion of the sun's energy to evaporate water, which keeps the surface relatively cool. This comparison shows what happens when that moisture runs out. Without water to evaporate, the natural cooling process stops. The ground absorbs the solar energy directly and becomes a dry radiator that only emits more heat into the air. Then there is the wind. In India, these dry, extreme weather currents are known as the loo. The human body relies on sweat to cool itself, but the loo is so intensely hot and arid that it strips the moisture straight out of the skin, vaporizing water before a drop of sweat can even form. The sky is blocking the exhaust, the ground is generating its own heat, and the wind disables the body's ability to regulate its temperature. Natural cooling has been neutralized. For those with air conditioning and reliable power, this weather is an inconvenience. But for construction laborers, traffic police, and delivery workers, the environment poses an immediate physical threat. In dense urban slums, the architecture itself becomes a hazard. Small houses with poorly ventilated tin roofs act like ovens by mid-afternoon, trapping solar radiation inside. Daily wage earners are forced into a corner. If they don't work outside, they cannot feed their families. If they do work outside, they risk total physical collapse. During a heat stroke, the core body temperature spikes to critical levels. Sweating stops, the patient loses consciousness, and without immediate intervention, their organs begin to fail. Official records only show confirmed heat stroke deaths, but extreme heat also triggers heart attacks and stresses the kidneys. Tens of thousands of suspected cases end up in hospitals, but the true mortality toll often goes unrecorded. A 50-degree heat wave exploits poor housing and forces manual laborers into dangerous conditions. It is an amplifier of existing economic and health disparities. As millions of people try to cool down at the same time, the weight of the crisis falls onto the country's electrical grid. This chart tracks India's peak power demand. In previous years, the grid handled baselines around 240 to 250 gigawatts. During this heat wave, the country has been breaking records repeatedly, driving demand above 270 gigawatts just to keep cooling systems running. Generating that much electricity requires enormous amounts of fuel. To meet the emergency demand, power plants have to burn significantly more coal. This cycle tracks our current loop. To survive the heat, we increase cooling demand, forcing higher power generation. Because that power comes from coal, it increases emissions that drive global temperatures higher, requiring more cooling to survive the next summer. Climate data shows extremes of 45 to 50 degrees are no longer rare. They are rapidly becoming the expected annual baseline. We are using the very tools that warm the planet to protect ourselves from the warmth of the planet. Until the underlying infrastructure and power systems are redesigned, our current survival mechanisms are exactly what guarantee a deadlier future.